Computer networking is the heart of the internet and essential to almost every application that we use today. And this is also very important in Kubernetes because applications running in Kubernetes need to be able to talk with other applications running in Kubernetes and even talk to applications running outside of Kubernetes. They need to be able to communicate within the cluster and outside of the cluster. So how do you make that happen? Every pod running applications in Kubernetes needs an IP address so that it can be located and traffic can be sent to it. But pods are ephemeral. They always go down and come up to meet the desired state of the cluster. So you need a stable IP address that pods can be reached on, and many pods can be attached to one stable IP address. See it as your router in your home network. So that's in Kubernetes called a Kubernetes service object. The service has one IP address and many pods with different IPs are allocated to it. There's also a need for pods to be able to be located easily within the cluster, right? So you need to be able to discover pods easily and efficiently, discover services easily and efficiently. If a pod goes down and comes up again, you need to know the address of that pod. Managing it like a phone book kind of system where every pod has an IP and you're able to find that, or the cluster is able to find that easily. This is all managed by the DNS. The DNS is the domain name server. Running inside of Kubernetes, you have an internal DNS that keeps records of all the IPs and all the pods and helps the cluster to be easily locate and send traffic to each pod. Also, there's a need for the Kubernetes cluster, pods and applications running in Kubernetes cluster to talk with other applications outside the Kubernetes cluster, and also to be able to be reached by applications running outside of the cluster, because your application can be a client or a server, so you need to be reached and do it to send traffic as well. So for that, there are three ways that you can enable external communication in Kubernetes. You can use the node pods. So every node within the cluster, every worker node, every master node can have a port, and you can open that port and map your pod to that port, and communication sent to that port on the node would reach your pod. But it's not always secure or efficient. So another way you can do it is to use something called a load balancer. So you can connect your Kubernetes cluster or your Kubernetes applications to a load balancer. Or maybe if you're running in a cloud environment or you're running in a data center environment, you can connect your load balancer F5 or Metal LB. Or if you're running a cloud network, you can connect AWS load balancer or Azure load balancer to your pod. But with this, you have many pods, so many services, each connected to its own load balancer, and that is a lot of money and a lot of expenses. So Kubernetes has a different object which is very efficient in managing this kind of problem, called an ingress. Your ingress resource is basically created as a load balancer that can help direct traffic to many services attached to it. So if you connect your ingress to an external load balancer, you can have one load balancer and traffic is sent to that load balancer and then to the ingress, and the ingress helps distribute traffic to its various buckets, which can be various services. So that's how external traffic can reach your pods within your Kubernetes cluster. These are just the basics of networking in Kubernetes. Kubernetes networking is a very vast topic, and we'll be talking about that over and over within our communications. Anyway, my name is Mark Elias, and I'm taking you behind the scenes of how applications actually run in production. See you next time.